we go. I want you guys to write this down, assignment-wise. It's on page 806. And I want you to just look at problems 1 through 8. That'll be due for Monday. Tomorrow when you come in, we're going to have quite a bit of time to look at some things together as a group and have some work time to accomplish some things. But just jot that down real quickly.
What is today?
The 13th.
No, like weekday. It's Thursday.
Hey, Mr. Carson.
Yeah.
Are you ever going to take this? We'll watch it.
Yeah, if you're done with that, I'll take that.
I've been. Oh wait, no, that's the one you said sass.
I'm the Divisible. Let me take a stuff.
All right, anybody need more time with that up there?
We were talking like March.
Guys good there? Good, guys? Okay. So you guys take a look at your notes today. And guys, in 4.1, we're going to start looking at factoring stuff and what it means to have prime factorization. This chapter is going to be a lot of this stuff right here. And a lot of the rules that I covered today are going to be applied as we move through some of the processes that we're going to discuss throughout this chapter. But guys, our goal today is to write the prime factorization of a number. Okay? And when I talk about prime factorization, I maybe at least have heard of prime factorization before. You may remember what it was, what you did with it. Okay. I think the first thing we probably need to do is decide on what the word prime means first. Okay. And guys, right up here, we've got the vocab here that says what are prime numbers and what are composite numbers. So let me give you an example of two. I'm going to volunteer to read what my prime number is here first. Selena, you want it?
Sure.
Okay.
A whole number greater than one that has exactly two whole number factors, one and
Okay, I'm going to give you an example of a prime number. An example of a prime number would be 7 because what two whole numbers could you multiply to make 7? What times what's going to make 7? 1 times 7. Is there any other combination of whole numbers that would make 7? No. So right here as an example, 7 is prime because its only factors are 1 and itself, right? How about 5? What are the factors of 5? 5 and 1. Anything else? So is 5 prime or not?
Yeah.
It is. Now here's one for you. How about 12? Do 1 and 12 work?
Yeah.
But are there another combination of whole numbers?
3 and 4.
3 and 4 would work. So is 12 going to be prime? No. Okay. 12 would be considered what kind of a number? Composite, because you could have 1 times 12. Or instead of 1 itself, couldn't I have 2 times 6? Or maybe 3 times what? 4. Okay. There are more factors than just 1 in itself, or 12, right? So if a number's not prime here, we're going to call it composite. Composite. Okay. Yep. We'll look at what prime factorization is here in a second, but how about a volunteer to at least read to me what prime factorization says? Go ahead, Maddie.
When you write a number as a product of prime numbers.
Sounds like an echo in here already. Okay.
It does.
Always got to be one crazy clown in the class.
It's Selena.
Yeah, you look it up in the dictionary. Selena's right there.
I know.
Okay. Prime factorization is what we're doing to write a number as a product of primes. What I'm going to tell you right here is when we do prime factorization, the process we're going to do or work with is to make factor trees to find our prime factorization. Factor tree is nothing more than a diagram used to write the prime factorization of a number. I'll show you that in a minute. Okay. This is what's kind of new right down here. This part, monomial. Might want to, I don't know, kind of talk about what this is. Monomial part, you might want to put a star or highlight it or something right here. This is going to be what's kind of new for you. Okay. Monomial says it's a product of numbers and what?
Variables.
First of all, the word product meaning what operation? Multiplication. So a couple of examples. Couple of examples right here might be, I don't know, maybe 24x to the second times y. Okay. Are there numbers involved in that example right there?
Sure.
And then when I say 24x squared, what operation's occurring between the 24 and the x squared? Well, multiplication, isn't it?
Yeah.
There's no plus or minus signs anywhere, basically. So it's a combination of numbers and letters, and no plus or minus signs. It's just all multiplication. Okay? So let me give you an example of what a monomial is not. What if I went 24x plus 7y? Why is that not a monomial? Well, it says product of numbers and variables.
Oh, yeah.
All of a sudden, is addition some kind of multiplication at all? No. Okay. The reason this is not a monomial is because it's got addition in it. Okay. All right. So let me clean that up quick. You don't need that part. A good example of a monomial: 24xy, or I'm sorry, x squared times y. Guys, what I want to do is I want to make a list of prime numbers up here, up to 100. I want you to make the same list, and we're going to use that today to help doing what we're doing. I also want to go over some division rules to help you with that for what we're going to be doing. So I think the two things that we're going to look at here should be things that you know, but if you don't, I just want to do a quick refresher on it, as that's going to help us throughout the rest of this today, okay? All right, so the list of prime numbers, you ready to roll on this? Write these down. 2 is prime, 3 is prime, 5 is prime, 7 is prime, okay? I'm not going to sit here and sound like a writing numbers guy, so I'm just going to write them down. Is that okay?
No.
I've got to say them all, Selena?
Yeah.
Okay, fine. 11 is prime, 13 is prime,
Because it acts.
17 is prime, 19 is prime, 23 is prime,
Good job, Sel.
29 is
I
prime,
just said he didn't have to.
31 is prime, 37 is prime,
I'm sorry, what?
41 is prime,
Wait, can you go back? I'm
43 is prime, 47 is prime, 53 is prime,
Marson.
yeah,
Can you step up? Can you go back 5?
59 is prime, back 5 feet,
No.
I just went back 5 feet. You never specified what kind of a unit. 61.
Such a nerd.
What's wrong with being president of the nerd herd?
I'm a geek.
A lot of things? A lot of things?
Can you just continue saying the numbers?
Slow down next time, please.
You're awful needy.
You guys can't look up here and write them down.
No,
No.
I was kidding.
Holy cows.
I think I'm gonna keep going hard and 10.
But slow down, please.
Yo, Marson, I can't see. Thank you.
I need a short. I can't hear you. What is going on? I'm scared.
It looks like he ran into his own mind.
Yeah, I think he went to
He went to a safe haven inside his mind.
Yeah.
Timmy's.
Oh, wait, shush.
Hey. Timmy's.
Hey.
Hey.
Okay, you guys. Taryn chills.
Go to 100%.
I am going up to 100.
He just had a thing. Get a brain. It's fine. You should be really shouldn't know. Guys, shh. You're getting ready.
There you go. Okay, stop when you get to 97, okay?
Hey,
Okay, so those would be the list of primes up to at least 100.
that one piece of there.
Pretty sure I have them all correct up there.
Look at this.
Or else what?
Just cut it off.
You look like an idiot. Hey, Parson,
You better
can
make
we,
all your baskets tonight, or else.
Or else what?
I'll run you.
Don't be Mr. Driscoll.
Parson, can we cut M's hair?
No, we're gonna do
They
that.
want to cut my unicorn horn off.
Yes, we need to cut it off.
Okay, you guys have those numbers down? All right, quickly, I just want to run through some division rules I think that are important for us to remember. So guys, division rules that are going to help you with prime factorization right here. I'm going to basically do division rules from the numbers 2 up to 10. And just jot this down, guys. 2 will divide into any number that is considered even. Okay? Even ending in 0, 2, 4, 6, or 8, right? Ending in 0, 2, 4, 6, or 8. So 2 will divide into any number that is what kind of a value again?
Even.
Even. right? Anybody know the rule for 3? How about you guys get your Chromebooks out?
It'll divide up.
And I want you to do a Google search on rules for dividing by 3.
Okay, Google, rules for dividing by 3.
Mr. Parson, isn't a rule basically it can divide any odd number except 1?
Not quite.
I got you, Parson.
You got an answer here?
I think.
What's Google saying? A rule for division of 3.
Here is a look for rules 3, 6, and 9. The rule for 3. A number is divisible by 3 if the sum of the digits is divisible by 3.
Okay, so here's the deal. You add your digits up, and I'll give you an example. Add your digits. Add the digits of the value up. And check to see if it's divisible by 3. Okay, so as an example, here's a number. I'll put the number up here on the board. The number is 177. Okay? In 177, I've got a digit of 1 and 2 sevens, right? What's 1 and 7 add up to for my first sum of digits? 8, and then 8 and 7 more would add up to 15, right? Well, guys, does 3 go into 15?
Yeah.
Do we know that fact? 3 divides evenly into 15, right?
Sure.
Therefore, by taking these digits from 177 and adding it up to get 15, and knowing that 3 goes into 15, we would say that 3 divides equally into 177. And, you know, I could check this real quickly just to make sure. Checking to see if 177 is divisible by what value?
3.
It is. How many whole times? What I get here? 59, right? Goes in there 59 times. So guys, your rule of 3 is add your digits up and then see after you've added all your digits up, check to see if that number is divisible by 3. Now if you weren't sure that it went into 15, here's the kicker on this. Watch this. If you weren't sure about 15, I could take 1 and 5 and add that up. What's 1 and 5 add up to? What does 1 and 5 add up to? 6. Does 3 go into 6? It does, doesn't it? So I could I could add digits multiple times here to see, okay?
Wait, I'm confused.
Add up your digits. 1, 7, and 7 add up to 15, right?
Not that. Because it said you have 2 and then you have even and then 3.
The rule for dividing by 2 is if your number is an even number. 2 will go into any number that's even. Good? 3's rule says it will go into any number that if you add your digits up and that number is divisible by 3, then 3 goes in there. Got it? Okay, rule of 4. Rule of 4, here it is. On a rule of 4, rule of 4 says check the last 2 digits. And if 4 goes into the last 2 digits, then 4 will go into the number. So here's an example for rule of 4. If I have the number up here, say 1,316,000. Ooh, that's a big number. I want to know if 4 goes in there. What's the rule of 4 say to do? Look at the last 2 digits, 16. Does 4 go evenly into 16? It does, doesn't it? Therefore, I'll say 4 goes into 1,316,000. Okay? So here's another example. 3,417. Will 4 go into that? No. Look at the last 2 digits. Will 4 go into 17? The answer is no way, Jose. Okay? Good on rule of 4? All right. Rule of 5. Here's rule of 5. 5 is very easy. Your number ends in 0 or 5. The number ends in 0 or 5. Okay? 75. Will 5 go in there? 75. Will 5 go into that evenly? Why? How about 99? No. All right. Rule of 6. Rule of 6 is very nice. Rule of 6 is a combination of rules for 2 and 3. The number has to be even and what? Got to add the digits up to see if it's divisible by what? 3. So the number has to be even and divisible by 3. Here's an example. Here's an example right here, 3,417 again. Is this divisible by 6? What's the first rule for the rule of 6? Gotta be even. Is this even? No. Is it gonna work? How about this number? 672. First of all, is that number even? Got this part satisfied right here. Then add 6, 7, and 2 up. 6, 7, and 2 add up to 15. Does 3 go into 15? So it's even and divisible by 3, therefore it has to be divisible by 6. You okay with that? Okay. Rule of 8 real quickly. Rule of 8 is just like rule of 4. However, you look at your last 3 digits instead of the last 2. Okay, you're going to look at the digits, the last 3 in this case. Check the last 3 digits to see if they're divisible by 8. If the last three digits are divisible by 8, then your number that you're dealing with is divisible by 8. I'll give you the quick rules on 9 and 10, and then we'll start rolling on some examples here, okay?
Wait, what's the last one?
Digits.
No, I mean.
The values. The digits are the values, okay? You just look at the last 3 numbers, okay? Okay. Rule of 9. Rule of 9 is very similar to the rule of 3. You're going to add your digits up again, but instead of being divisible by 3, you want to be divisible by 9. Okay, so let me write that down. Give me 1 second. Got it? All right, kiddos. So let me write this down. You're going to add your digits. Add the digits. And see if it's divisible by 9. If the number you get after you've added up is divisible by 9. So an example, I'll wait till you have that down. Let me know when you've got that written down. We'll do an example. For the rule of 8, you're just looking at the last 3 digits. Okay, we are on 9. 9 says to add the digits and see if it's divisible by 9. So an example for something like this, I don't know, how about 350, that's a bad one, 351, okay? Well, I know 351 is divisible by 9. So by the rule of 9, what am I going to do with a 3, 5, and 1? What's the rule say for 9? Add the digits. So I'm going to add my digits in 351. What's 3 plus 5 right here? These all add up to 9, right? So when these add up to 9, when I add these 3 digits and get 9, does 9 divide evenly into 9? Does 9 divide evenly into 9? It does, doesn't it? Okay. So we know then that 351 has to be divisible by 9. How many times here? Let's just check it and see. What did I get here? Okay, so 9 times 39 is 351, right? Okay, so that's what's going on there. And then the rule for 10 is very simple. Rule for 10. Anybody know it, by the way? Rule for 10?
Solve.
Ends in a, what does 10 end in?
0.
Any number that ends in 0 is divisible by 10. Any number that ends in 0 will be divisible by 10. Now, if you notice from 2 up to 10, I skipped a number, right? What number did I skip?
Uno.
Well, from 2, we don't care about 1. 1 will go into anything, right?
Oh, 7.
7, right? Let's put a rule up here for 7. 7. Here's the rule for 7. You ready for it? Check it in your calculator. Which you could do with all of these, couldn't you?
Sure.
But I'm just trying to help you speed things up. These rules here, again, I would say if there's something that kids struggle with in pre-integrated math, sometimes it's just calculations. Okay? So these rules are here for you to help you try and figure out if a number is divisible by some of these digits right here, up to 10. And I think if you pay attention to what's up here, or been paying attention to what I've told you, this should be pretty simple to apply. Okay? All right. List of prime numbers and the rules of division. Do we have those down at least? Okay. Let's see if we can't put these into action on the second page. So if you'll go ahead. Everybody's got this before I put this? Yes? No? Yes?
I don't understand. What are we like, if you're dividing by whatever number?
Taryn, I'm saying if I have a number that I'm trying to figure out if I can break it down. If a number ends in 0, 500 for instance, ends in 0, right? If a number is 500, what number has to divide evenly into it? 10.
Why would I get like other?
Number 6, rule of 6. If your number you start with is even and divisible by 3, then you can divide it by what? 6. The example I used in this was 672. Is 672 even? Okay, so we satisfied this condition, right? And then I need to see if 672 is divided by 3, right? Well, add these up. When you add these up, that adds up to 15. Does 3 go into 15? Yeah, right? So it's an even number that is divisible by 3, therefore what must divide into that? 6. Okay? It's just going to take some practice. We'll get there. Okay? Don't panic now. Just have the rules down for now. Okay? Got them? Okay. Second page then here real quickly. We'll look at the notes that I've got here. You guys, I think that this will help out right here. Example 1 is going to talk about writing factors. Sometimes up here I like to say that what we're really doing is listing factors. Okay? We're listing factors. Guys, the example I give you is that you've got a rectangle right here. And I'm going to say in this rectangle that you have an area of 18 square feet, which means if I take my length times my width right here, the number of square units on the inside of this would be 18 square units. Okay? So we're saying that no matter what I do with the length and the width, when I multiply them together, what value do you get? 18, right? Okay? All right. Right below it, it says write 18 as a product of 2 whole numbers in all possible ways. I'm saying write down a list of ways that I can come up with a product of 18. Now, anytime I say list the factors of a number, I like to circle this letter T right here. Okay? List ends in what letter?
T.
T. All right, here's how I do this. Anytime I'm given a chance to list all the factors of a number, here's what I do. I make a T chart. Okay? All right, I make a T chart. List. Use the T in list. And right up above here, I'm going to put 18. We're trying to come up with values for a length and a width that would multiply to what value? 18. Well, guys, what whole number will always divide into another whole number every single time? Not 2. 1 goes in there all the time. 1 is always a factor, isn't it? Of whole numbers. Okay? So the way I make my list here, gang, is this. I start out and do this. 1. Will 1 go into 18? How many times? 18 times. 1 itself will always be a factor. Okay? Then this is where your rules of division are going to come into play. Does 2 go into 18?
Yeah.
How many times?
9.
9. Okay? 2 goes in there because 18's even, right?
Yeah.
Oh gosh, wasn't that one of the rules I gave you? All right. 2 goes in there 9 times. How about 3? Does 3 divide evenly into 18?
Yeah.
How many times?
6.
So 3 and 6 I put down there. 4 go in there?
No.
5 go in there.
No.
The 6 go in
Yes.
there. Now hear me out on this. 6 goes in there how many times?
3.
However, when I put a 3 up there, didn't we already account for
Yeah.
a 6? Okay, so how do you know when you're done listing factors? Well, in this case right here, as you're moving down the left-hand column, the second you get a value that overlaps something that you already have on the right, shut it down. You're done there. Okay, so in other words, 4 didn't work, 5 didn't work when I checked it. I get to 6. 6 works, goes into 18, right? But didn't I list 6 here already? So my question is, what are the factors of 18, really? What are the factors of 18? You would say 1, 2, and 3, and what after that? A 6, a 9, and what other value? Okay, those are your factors of 18. All right. So what I want you guys to do real quickly is this for me. I want you to jump to the last page of your notes, and on your own, right here, I just want you to try the top 2 numbers. I want you to list the factors for 28. I want you to list the factors of 48. And once you've got those sets done, check with a neighbor around you and see if you agree. Okay? So on the last page, flip over to that last page, do those top 2 on your own, all right? Yeah, make a T-chart. Yep, make a T-chart. That's the easiest way to do it. And I'm not saying, Maddie, when you come up and ask something like that, I'm not sitting here telling you, must be a Green Bay Packer fan in here.
Okay. Miami Dolphins fan.
And you're wearing green.
Evan, punch
I
it in
support
water.
John Deere.
Yeah, okay.
By the way, this is not,
I forever watched that.
it's not like ugly green wears.
Yeah.
This is a nice,
I'm going into
Forest
into
green.
Viking land.
Oh, boy.
Tomorrow.
I don't think he gets it.
Yeah, Viking land.
you don't have to list them right here. You can just leave it like this. That was what I was getting at here before I was seeing all
Hey,
over.
I have a question for you.
Yeah.
Do you know where Winona, Minnesota is?
Oh, yeah. Been there a
How
while.
long does it take to get there?
About 2.5 hours.
Okay.
Taryn, what's the question? Yeah, if you want. What I would do with 28 there, Taryn, make your T-chart and start at 1. And just go right down the line. Does 1 go in there? How many times? So put 1 on the left, 28 on the right. And then check. Will 2 go into 28? How many times? 14? Does 3 go into 28? 4 go into 28? How many times? How many times does 4 go into 28? 4 times what makes 28?
No, because Jack goes 2 times 4 is 8.
You got a calculator?
But so much stuff.
I could totally.
Okay, Mr. Marshall.
factors of 28?
Yeah.
We'll put them up there, won't we, bud? Alright, make me a T-chart up there, okay? Put it on a different sheet of paper for me, Timmy. So it's just like, you know which one to push up there to get a clean sheet? The white page with the green plus up there at the top.
That one?
Yeah. Okay, write your number 28 up there. We're gonna list the factors of 28, and then right below your 28, oops, hit your pen option there. Good. Alright, 28. Put a T-chart under that, kiddo. Alright, here we go. What'd you put down for factors of 28? Two goes in 28 14 times. 4 goes in 28 7 times. Any others? No, and again, same thing. If I gotta check 5, nope, not gonna work. 6, not gonna work. 7, when I get to 7, just gotta check. But isn't 7 already accounted for on the right?
Yep.
So once I overlap that right side value, you are done. Who wants 48 for me?
Come on.
You want 48, Candace?
Oh, I'll do 48.
Candace, your call. You want her or do you want to do it?
Okay.
Alright, have
Give it to
Candace do it.
Candy.
I'll get you up there for another one here in a second, okay, Daddy?
Yeah.
48, just put it right on the same page. T-chart 48 for me. I'm listing all. What?
If you ever watched Doctor Who, you know what I mean by socks. Oh,
Never watched Doctor Who.
you should. It's on Netflix.
I watched Dr. Math.
That's a nun.
Listen, dude, there was a possum in my garbage can last night. I took it like a zombie. Don't make me do the same.
There was a possum.
Yeah, I seriously went outside and kicked the can over because my wife was freaking out, and I went zombie on the possum and it ran away.
What do you mean zombie? That's
No.
Oh, tell him the puppies joke. You should have told us the puppies.
What?
Are you
Oh. Maddie,
yeah.
let's check her math up here first, and then I'm gonna get them for you.
Okay.
1 and 48, I agree. 2 and 24, I agree. 3, 16, 4, 12, 6, 8. Very good, Candace. Make sure you've got those
Okay,
down.
now tell me the joke.
Hey, Maddie.
Yeah.
Need a bet?
No.
You know why? Because these puppies are sick.
Carson, that's not funny.
She's laughing.
Okay, wait.
Carson, that's not funny.
Carson, hey, do you know where Rolling Stone, Minnesota is? Oh, it's like 10 minutes from Winona. It's really small.
No, Winona is a nice town, I think.
Yeah,
Okay.
I'm staying at the Holiday Inn, I guess. I don't know.
Do you guys have these listed right here? Got the
No.
list down? Get them down.
Yeah, I
Get 'em
have
down,
them.
get 'em down.
Kitty.
All right.
Daddy.
Okay,
I have it.
let's jump into the stuff that we're really going to start working with then, all right, guys? That's the idea of listing
Carson.
factors right there, okay? Yes.
Oh, wait, never mind.
Okay, now, what we're going to start getting into here now is writing stuff as a product of primes. This is where we're going to start making factor trees that I talked about in the vocab to go ahead and do prime factorization. I want you to make sure you understand what it means to list the factors and how that differs from prime factorization. So, in example 2, it says write the prime factorization of 420. Your job basically is to break 420 down. Now let me help you with this real quickly, guys. 420 here, what value does that end in?
A 0.
Last value or the last digit is a 0. So by your rules of division, what would probably be one of the larger numbers? 10 will go in there, okay? It turns out 420 is the same as 42 times what value?
80.
Ah. 42 times what? 10. Okay. Now if I go back to my list of primes right here, does either 42 or 10 show up here?
No.
No, neither one was prime. So that means that 42 and 10 can be broken down even
More.
further. So I'm going to go back to this idea right here. I need to break 42 and 10 down. Guys, can you think of two numbers that multiply to 42?
Yes. 6 and 7.
6 and 7. Okay. Okay. Is 6 on the prime list?
Sure.
The only even number that's on the prime list is 2. Every other even is always going to be composite. Is 7 on the prime list?
Yes.
Anytime I have a prime value, I want you to do this. Circle it. Okay? Help me break 10
Hey,
down.
I remember this.
You remember doing something like this, don't you? Okay? Don't lose sight of this, because what we do with this, we are going to do a lot of stuff with this that's going to get in with
Wait.
multiples and factors and fractions. And
I know it's on here 2 and 5.
2 and 5. Is 2 prime?
Yes.
Circle that. Is 5 prime?
Yeah.
Okay. What number haven't I circled yet as I
Six.
break 6? Can 6 be broken further?
Yeah.
3 and 2.
2 and 3, which are both what?
Prime.
Okay. There's no more numbers to work with. I've circled all I can.
Keep going.
So below this, I just want you to draw a line, and I want you to list your composite, or I'm sorry, your prime factorization in order, or in ascending order, if you will. So let's go through with this. I've got some 2's down here that are part of my prime factorization, right?
Yeah.
Prime factorization says you can write any whole number as a product of primes. In our case here, how many 2's do you have?
2.
So you're going to call this 2 times 2. There's 2 of them. What's the next value in order?
Wait, are we writing in the factor?
Doing what? There's a 3 that was in here that was a prime factor, right? You guys agree? Isn't a 5 another prime factor? And isn't 7 another prime factor? You guys okay with that? Now what this means is the following. It means that if I could take all these prime numbers and multiply them together, they better get me back to what starting value here? 420, right? So watch what I do here. I'm just going to punch it in. Here we go. 2 times 2 times what other value? What's next? Times a 3 times what?
5
Times 5 times
7.
7. Better put me back where? 420. Do I get there with that? Okay. So I say the prime factorization for 420, or in other words, the prime numbers that I would use to multiply to get to 420 are what values? Well, it's 2 times 2 times 3 times 5 times 7. That makes sense? All right. So quickly, how does that tie into what the next part is? The next part says, oh boy, do the prime factorization of a monomial. They would have to start throwing letters in there, wouldn't they? That's kind of mean of them, isn't it? Well, here's how you handle it. It's exactly the same way. Don't worry about the letters to start. What value do you think I'm going to break down first? 24, right? Okay. Can you guys help me with 2 numbers that multiply to 24?
Oh, 6 and
6 times 4 would work. Would 2 times 12 work?
yeah.
Would 8 times 3 work? Okay. I'm going to go 6 and 4 since that's what I heard first, okay? So help me out. 6 and 4. Can 6 break down further?
No. Yes.
To what?
2 and 3.
What I'm telling you guys right now is this. I'm going to circle the 2 and 3 because they are both prime. Handle the value up front. Don't worry about any letters or exponents just yet in some kind of a monomial. How about 4? Can that break down further? 2 and 2. Can I go any further than that then?
Nope.
Done. So what's the prime factorization for my 24, guys?
2, 2, 2.
Well, 2, 3, 2, 2.
I'm going to put it in order. Okay, 3 2's out front. Is that okay?
Yeah.
Times the 3. You guys agree that this would get me back to 24 right here, right?
Yeah.
Okay, now, how do the letters come into play here? Well, to write the prime factorization of a variable, you're just writing a variable down again. However, this really says x to what power?
4.
So how many x's do you think I'm going to follow up with here now?
4.
4 of them. And then what's the last thing you think I'll follow up with?
A Y.
A y. There's just one of them, right? This part right here is 2 times 2 times 3. I'm sorry, 2 times 2 times 2 times 3. What do you think that multiplies to? It'd be 24, isn't it? Okay. What's this part right here? That's the x to the what? And then this is just your y value, okay? You're doing the same exact thing. You just worry about the prime factorization of your coefficient or your value out front. Do the prime factorization of 24, which we've done here. So the solution we end up with,
So that's all we do. You don't.
that's all you do. You don't really worry about the letters. If there's 4 x's, you just write 4 x's. If it said x to the 7th, how many x's would I have to put in there?
7 on 2.
7. Okay. So are the variables really a roadblock, or are they just kind of a nuisance? Nuisance, yeah. Okay. It's kind of like when somebody says, "Pull my finger." That's a nuisance. All right. All right. So here's what I want you guys to try next. Just gonna tell you real quickly, and you're on your own here. We kind of listed this right here. 97 is going to be a prime value. 117 is composite. And I'll tell you 117 is composite because what's 1, 1, and 7 add up to, guys? 1, 1, and 7 adds up to 9, doesn't it?
Yeah, that.
So 9 would go in there. So, all right, here's what I want you guys to do. I want you to make me a factor tree for the prime factorization of the two monomials here. So what value am I really breaking down here?
21.
Okay, and then you got to put some ends after it, and then I want you to break the 18 down there, and then put your variables in. So I want the prime factorization for those two monomials. So go ahead and take a second and do that. Then we've got an answer, check with your neighbor. And if you disagree, you talk about why you disagree. Need more time with those?
Yes.
Shouldn't take too long. All right, let's talk. Guys, 21, what'd you break that down into? 3 and 7. That's nice because 3 and 7 are both what kind of values? So I'm going to write this as 3 times 7. That's the 21 value. How about the variables after the 3 times the 7? 5 n's. So n times n times n times n times n. How many had that? 3 times 7 times 5 n's after that. It's not too bad, is it? Okay, help me break the 18 down. What does 18 break down into?
Well,
Not 2 and 6.
I did 3 and 6.
3 and 6.
Oh yeah, that's what I meant. I said 2. I don't know why I said 2.
That 3 would be prime, so 6 could go further.
2 and 3.
2 and 3. Okay, Maddie, you got her, kiddo?
Yeah.
Maddie, you got a question?
Yeah, on our worksheets and stuff, when there's like the N5 or something, do we have to write it on
I want you to get in the habit of that because eventually what's coming here, quickly, Maddie, is we're going to start looking for what's common. It's a lot easier to list them out. So yeah, I want you to get in the habit. Good question, but yes, I want you to do that. It would still be the same if you put n to the 5th, but it's going to save you a ton of time down the road. So I just want to put you in that habit now. Does that make sense? Okay. So what's the prime factorization for 18 in ascending order?
3, 2.
So 2 times 3 times 3, right?
Yeah.
How many x's behind that?
2.
How
2
many
X's,
y's,
3
guys?
Ys.
3.
Okay. Very good. Nothing really different than if it was just numbers, right? You just gotta go ahead and fill in the variable part of it. Okay, kind of a nuisance, I get it, but I think for the most part we're okay with it. All right, so just as a quick reminder, any questions on the notes first? I guess I should ask.
No.
Quick reminder, when's this book page due? Monday. Okay. Let's see. We've only got about 9 minutes, so I'm gonna